Hey everyone, welcome back to GraphQL Scale 2022. I hope everyone had a great chance to get a stretch, a drink, and maybe even a chat in the networking rooms. We've got our last block of the day of talks coming up. So to begin with, let's welcome to the stage Jesper Rasmussen, lead software engineer and dev advocate at TV2 Denmark and TV2 Play. Now Jesper's going to talk about transforming the monolith into a federated graph. Thanks so much for being here with us, and welcome to the stage.
Thank you. All right, so let's just get started here. So today we're going to be talking about how to scale a monolithic GraphQL setup into a federated graph. And in this presentation, I'm going to lead you through like 4 subjects that I think are pretty crucial if you're looking into rewriting your existing GraphQL setup into something that supports federation. And the principles that we'll be walking through will probably apply to your setup no matter what your setup looks like, or at least some of it will. So let's just get started here. So just here, just to make it short about us, this is us. We're TV2, and TV2 is the largest commercial television broadcaster in Denmark. And we also run the largest commercial streaming service for video in Denmark. And we've been running GraphQL since 2016, which makes us pretty early adopters on that. And we are currently running around 900,000 subscribers on the premium service. And doing so, we have around 3 billion operations during a month. And whenever we do queries or mutations inside GraphQL, we try to keep our response time within 100 milliseconds across the board. And so let's have a look at this old monolith that we used to have. So this is the old platform, the old video platform that we used to have. And as I mentioned before, we've been running GraphQL since 2016. And this old API used to serve metadata and data to all of our customer-facing applications. And so it was basically serving up all the content needed for streaming. And the old platform here was based on a bunch of REST-based microservices running in Kubernetes and having this single monolithic GraphQL API gateway in front, as you'll see. And in that way, our adoption pattern of GraphQL is pretty much one of the most common ones. And so during these 6 years, we basically came up with 2 major issues with this setup. And as we began to scale to several 100,000 subscribers, we saw some different issues. And one of the things that we saw was that this third-party metadata service that is on the bottom of the screen here was really not scaling as well as we would like it to. So we ran into some issues where this service would be a bottleneck whenever we reached prime time. So whenever people were streaming at night, we would see issues where this service that we didn't own didn't scale well. So we wanted to, during the period, we wanted to basically cap it off or isolate it even more and more. And basically wrapping it inside caching systems and avoiding to have too much traffic on that. The other issue that we had with this particular setup was that we had this monolithic API gateway. And the main issue around that was that it ended up actually having a lot of business logic. And during the period of time and over 6 years, you can probably imagine that if you have business logic inside your API gateway, it will end up mutating over time, and you'll have like a lot of legacy code and old business rules that don't apply anymore. And we basically wanted to get back to a state where the actual gateway or the API front layer was more simplified routing layer, instead of having something that's monolithic and in doing so having something that would be hard to scale. And so as the need for different features kept arising, and we saw different challenges on scaling the setup, we basically decided 2.5 years ago that we wanted to ditch this dependency on the third-party metadata service, and we wanted to rewrite the entire video platform. And in the process of doing so, we basically rewrote all of our services from scratch, and in the process moved to a more federated setup. So in doing so, the first challenge that we actually faced was the actual transition from the old platform and onto the new one. So let's have a look at how that was actually planned. So when moving from the old platform to the new one, we had a pretty big issue in which that we switched all of our IDs, so internal IDs for content, was switched to a completely new setup, which meant that we basically changed the ID space for all content, which also meant that we pretty much couldn't actually reuse any component in the new platform. And due to this restriction, we actually ended up building an entirely new setup next to the old platform, and then we basically rewrote all of our services using this new setup, and in the end tested everything and moved all of our clients from the old platform and onto the new platform. And so doing that in parallel and actually having two systems running at the same time, and then having testing on all different client platforms at the same time, is just something you really don't want to do. It has a lot of issues, of course. We couldn't actually test our new platform for the doing load tests, for instance, because we were basically running traffic on the old platform and on the new one. We couldn't actually test clients on the old platform and the new one at the same time due to this difference in IDs. And basically just doing this meant us doing double development and also doing being actually unable to migrate at a simple way. So don't do that. So instead, let's talk about strangling instead. So a pattern that's being pretty common for removing legacy components or rewriting old software over the last years is the strangler pattern. And the concept's pretty simple and pretty straightforward. So if you have like legacy code or a legacy functionality that you want to remove, what you would do to strangle it is basically adding new functionality around it or adjacent to it, and basically having this new functionality take over the functionality of the old software or the old logic, and then eventually like moving components one at a time. You would end up having no dependency on the old logic, and then you would basically strangle it as no one would actually need it anymore. So let's have a look at the old platform yet again and see how we could have used strangler pattern if we actually had the option to do so. So of course we didn't due to the ID space issue, but let's have a look at how we could have transitioned if we had actually had the option. So if we wanted to move the old platform onto the new one and doing it by actually applying the strangler pattern, what we could do is consider the entire old platform as one single schema representing the first actual graph service inside our federated setup. And in doing so, the first thing that we would probably do is that we would introduce like a federation router, a gateway for doing federated schemas. And then basically by identifying different contexts, things like, let's say, everything around doing playback, by identifying the components on doing that, we could move the actual schemas into separate services one at a time based on their context. And then over time, as you would progress, you would move more and more services into this new federated setup, where all the services would then basically be rewritten, be federated, and potentially even span across multiple teams, as indicated by the different colors here. And then eventually, as you had isolated all the different services, you would then, as you would see here on the left, you would no longer have any dependency on the old monolithic API gateway, and there will be no dependency on this third-party REST service, and then we could basically just kill off the old setup. So that's what you could have done, and that would probably what I would suggest you would supposed to do if you are going to a federated setup. So let's talk about rewriting. So in general, you really don't have to do a lot of rewriting if you're moving to a federated setup, and I would probably suggest that you do as little rewriting as you possibly can, simply due to the fact that you will add more potential error risks in doing so. And the reason for us actually doing rewrites is that due to the fact that we were removing this third-party service, we also removed some functionality, or we had to recreate some functionality that we needed to implement yet again. And in the process of doing so, we actually had to rewrite parts of the schema, simply due to the fact that as we took over some of the functionality from this third-party service, we didn't have the option to actually implement it in exactly the same way, due to us wanting to do things differently, or simply by the closed source nature of the system that we were depending on, that we couldn't replicate one-to-one. So we needed to do some rewriting, and in the process of doing so, we wanted to make it as safe as possible for the backend developers, or the API developers, as well as the client consumers. So we came up with a few principles for making the process of rewriting actually as safe and as simple as we possibly could. So the first principle we had was keep it simple. So we wanted to keep as much as possible of the old schema that we could. I mean, we have a lot of different clients. We have clients running on a lot of different platforms, from TVs to mobile devices to Chromecast. And we really didn't want all client applications to be rewritten using some new schema if we could avoid it at any cost. So we wanted to keep the schema as close as we could to the original setup. And when we did do rewrites, we wanted to rewrite with care. And by doing that, what we meant was, if we wanted to do rewrites, or we had to do rewrites, we would at least keep the functionality, or potentially enhance it if we had the option to do so. So we had a few places where we had the actual possibility of improving old functionality that had existed for 6 years, and that client developers had been annoyed about for a couple of years. And by doing communication with the client, the application developers, or the consumers of the API, we were actually able to do rewrites that actually improved the API. We also wanted to add some more flexibility to the API. We wanted to make the API more flexible for application developers, but we also wanted it to be more flexible in terms of adding new functionality, adding new teams to actually provide data through the GraphQL API as well. So that was one of the principles as well. And then the final one was that we wanted to share the responsibility. So the old platform that we were running was basically being run by a single team. And over the course of years, we have had multiple teams wanting to expose data through GraphQL or through the API that's running our streaming service. But we've also seen demands from application developers wanting to be able to handle more things from different teams inside the company through a singular GraphQL endpoint. So we wanted to share the responsibility. We wanted to add more teams to the API, but we also wanted more teams to actually own the API in terms of actually running it. And so these 4 principles pretty much helped us along the way in terms of doing the actual rewrites. But the overarching point here is that the main component for us was just pure communication. So communication with the actual application developers, making us we wanted to, of course, have the transition as smooth as possible for them, but we also wanted this to be as safe as we possibly could. And communication just was pretty much key for every single decision we took inside this project. All right. Now let's talk about performance. So performance is a pretty big deal for us because I mean, who wants to use a streaming service that's slow? At least inside Denmark, when we're running into the World Cup in soccer soon, we know that if we have pretty poor performance on the streaming service, people will probably want to kill us. So we don't really want that, and so performance is a pretty key element for us. And in the transition of moving to a federated setup, just having the eye on performance, or having the goal of performance, made us face some new challenges that we hadn't seen before with the old monolithic setup. So let's have a look at the old setup again. So this is like a simplified example of something that we actually encountered during the rewrite. Now, the old playback service shown here has or had some dependencies on some downstream services handling metadata for the actual content that you want to play back, but also handling rights management. So checking if you have the correct rights for actually doing the playback. Now, in the process of actually moving to a federated setup, we were considering some different options on how to actually transition this service, or transitioning the actual context of doing playbacks. So the first thing that we actually tried doing was this. So transitioning every single of these three services into being pure GraphQL subgraphs or services that expose a GraphQL schema. And that was the first thing that we actually tried. I know you'll notice here that there's like a lot of errors going from the federation router to all the different services here below. And one of the things that we actually found out was that during this, having this strategy, or doing this tactic move, we actually ended up having a lot more traffic across the different services, simply due to the fact that when you wanted to do playback, so you would go to the playback service first, and then that would need some data from the metadata schema, and then you would need some data from the rights management schema as well, and there would basically be a lot of round trips from the different services in order to actually fetch the data just using GraphQL. So eventually we actually decided that this was probably not the best approach for us, also simply due to the fact that these services don't all need like a schema or need to expose the schema, because rights management, you really don't need rights management schema, at least in our setup, because you don't need to look up rights if you're not actually doing playback. So we eventually ended up grouping this in a playback context, where the playback gateway would be the only thing that would actually expose a schema, and then it would just have some downstream dependencies still running REST. Now, this actually allowed us to keep some control on doing cache handling inside the playback gateway. It allowed us to actually be able to control a lot more around how the actual network traffic was flowing between services. So this is what we ended up doing. And there's also one of the things that is pretty much key here, is that you don't necessarily want all your services to be federated or exposing some schema. It is quite okay to have some gRPC or REST service still running inside your setup, because it might give you better performance. But in general, there's like a few issues here that you will probably want to consider. So you want to consider, how is your actual network traffic changing when you're going federated? You want to consider, so your caching patterns, if you're doing that, will probably change due to the fact that you're looking at things in a different way. And then the actual traffic flowing between services is going to change as well. All right, so let's move along to reach the final thing. All right, so a lot of the issues that I mentioned that we had, we solved basically by applying different patterns and solving one issue at a time. But we still have a few issues remaining, and this is pretty much the most soft part of this talk, and that's the organizational part. So just wanted to highlight a few things that you probably want to consider if you're going to a federated setup and you're scaling across multiple teams inside your organization, and you want more teams to actually provide on a GraphQL API. So first thing, is everyone committed? So if you're a single team inside your organization and you're doing GraphQL and you love it, and you want to spread that, the other teams that are supposed to deliver to your API or provide data through your API, do they love it as much as you do? Or is everyone actually having the backup from management to actually go GraphQL across multiple services? Second of all, is everyone actually ready? So one of the things that we have inside the TV2 organization is that we've been running GraphQL for 6 years, but that's mostly like one team having run that. So we have some teams that want to actually provide GraphQL APIs, but they don't necessarily have the same level of knowledge or having made the same stupid mistakes that we have. So is everyone actually ready to actually provide GraphQL services, or do they need like a helping hand on getting started, learning best practices in terms of running the GraphQL setup? All right. Whew. What's the end goal? So what's actually the end goal on doing the federated setup? Do you want your API to actually provide features faster? Do you want more teams to actually deliver data through your API, either due to demand by consumers, or is it based on your product evolving at a faster pace? That's also like a pretty good thing to consider. And then the final one, how do you actually avoid having bottlenecks? So if you have like a single team that used to run this and you want to spread it out, make sure you don't have any unnecessary bureaucracy in terms of having someone needing to, over time, having to approve schema changes to the federated schema or things like that. Try to actually empower your developers to make informed decisions and trust them to actually do what's best for the actual API. All right. That's a lot of things. We covered 4 key elements to this. So I just wanted to leave you like a few key points from here. And the first one is that communication is hard. So if you're doing this, if you're going from a monolith to a federated setup, and this pretty much also goes if you're designing a completely new schema, try to focus on the needs of the consumer of the schema when you're doing that. A lot of things that we used to do was based on the data that we had available, or things that we decided would make sense to expose through the schema. But we actually ended up figuring out that the clients actually didn't need a lot of the field set or a lot of the objects that we were exposing. So try to focus on the actual needs of the consumers if you're doing this. Baby steps, yeah. So going back to the strangler pattern, try to do this in as few small steps as you possibly can. This will help you a lot, and it will make you ensure that your performance is on point, because you can basically monitor if the changes that you're doing are actually having a better or a worse impact on your system. And finally, and as I just mentioned, try to measure your changes, try to optimize your changes, try to keep focus on, if you're doing one thing to move towards a federated setup, will this actually make your network latency worse? Will it make the performance better or worse? Or does it actually need you to reconsider caching or things like that? That's all for me. It's a lot of talk. I'm sorry about that. And good luck with your federated setup. Thank you.
Perfect. Bye. So let's get some applause in the chat for Jesper, and thank you so much for being with us today. We unfortunately don't have time for Q&A after yours, although you do have an interesting one from Alex in Hopin. If you want to hop into to that interface and do it in text, that'd be great. But thank you so much for sharing your insights with us today.
Sure. I mean, it's I'm kind of, I need some water now because it's like a very intense operation.
Exactly. Move to text-based communication over verbal. I'm with you.
Yeah.
All right. Thanks so much.
Sure.